Okay, so today it's a continuation of the quantification of drawings, but we're going to move into the focus of steel buildings and mechanical equipment. What we're going to try to focus on today are to articulate the process, which is more of a review because we did cover that the first time, so we'll cover that fairly quickly today. And then the development of quantities for building construction, structural steel, and equipment applications. We'll talk a little bit more about that as we go, of course, but I think the general building construction application, there's probably several that's attending this course that actually know as much or more about that than I do. So we'll walk through those steps and seek everybody's comments or some additional comments from others on that topic. So just a quick review. We know what quantity development is, so we'll step through that one. To recap on the discussion of having some detail in request, and really what this transposes to is the description that you're including in your MTOs. So not only is it important for whoever's requesting and describing the scope of work and the request, which is partly what this statement or this slide is focused on. But when you transfer that information into your MTO, it's always helpful to put as much descriptive information in your activity label within the estimate as you can. I know there are different systems that allow you to incorporate different information. For example, in some of the Excel based programs that I've worked with and even assembled, it's kind of an open book. We'd have two different description columns. One was very rigid, and you had to put in certain things because it acted just like MC squared or one of the other programs. So it was forming a lookup, so you had to pull in something that was very descriptive and met the requirement of the lookup. But the other one it was free flowing. It's whatever you wanted to put in there. So you could then add that it's for this foundation or it's this PSI or whatever it needed to be to make the two descriptions work together and tell you what it is. Other ones like MC squared or WinEst or Timberline, they all have predetermined descriptions in the database. So when you pull the activity, it's pretty much already set, but they're usually fairly descriptive in themselves and provide you information so you know what that activity is about. I know I've got two examples here of concrete and a pipe, but it's a general statement that really applies to everything that's input. Key quantities, we covered that last time. Does anybody have any questions about key quantities? The main point here is just be aware of what your key quantities are, and as you input your quantities and activities into the estimate, tailor what you input for your unit of measure for each activity so that those items that are key quantities will flow to the key quantity in the summary sheet, and everything else will not. So if your key quantity is lineal foot, then feel free to use lineal foot period or feet or lump sum or lot or each or something other than lineal foot, so that the lineal foot items will accumulate. Everything else will be accounted for in your hours and in your material dollars and in your labor and subcontracts, but it won't drive that key quantity. So it will maintain your metrics and your measurements for analysis in the future. Again, today we're going to focus on structural steel, buildings, and equipment. Allowances, we talked about those last week. The main point there is include them as you need. Not every line item requires an allowance to be applied to it. If you have an instrument and you've counted that instrument, then the instrument is what it is. Same with a piece of equipment. But if you have something that's pipe or steel or cabling, and you know that there's a design issue with it, that it could change, the volume or description could change. There's waste with drops and cuts and overbuy, then that would be included. The design allowance for instrumentation and capital equipment, that doesn't apply to the quantity, but it does apply to the value. And it'll apply to the value only. Your labor to install that is going to be consistent, but it's the price that may change if the design adjusts slightly. So again, these are somewhat subjective in their magnitude, but the practice is consistent and objective. Any questions on allowances? Okay.
Sorry, I had a question on the allowances. I noticed on your spreadsheet that the only column there was for design allowance. And I know we talked about um, waste allowance and um, engineering allowance and that kind of thing. Is that, do you add that as you think you need it to the spreadsheet when you're doing an estimate, or is that something, do you calculate that somewhere else?
Yeah, that's a good observation. I When I typed in design allowance, I meant all of them. So it's if you have because actually in the MTO template, all you have is waste. I mean, all you have is quantity calculation there. So it really applies to MTO, waste, and overbuy, and less design. So that would be an adjustment to the template that I probably should take back, because whenever we talk about the design allowances at Fluor and Black and Veatch and so forth, we are actually talking about all of them, but that isn't always clear since one of them is called the design allowance. The way Fluor gets around that is they call design allowance mech and spec, while Brown and Root will call it design allowance, and Black and Veatch will call it design allowance, meaning the exact same thing. So it's a nomenclature issue. I appreciate that. I need to just change it to allowance, I think, and that'll make it a little more clear.
I'm glad to hear that because that's how we used it.
So that would be, yeah, that's the proper way. In the estimate template itself, you'll notice that each one of the columns in the detail section has a built-in column for ratioing and adding allowances and so forth, and that would be where you'd put the actual design allowance for the equipment and for the instrumentation, because normally as far as quantity is concerned, there's not near as much fluctuation in instrumentation quantity that they may find as things progress a few more places they need an instrument to monitor flow or vibration or something they didn't account for. But the equipment list is pretty well set. The only thing that's not set is the price that goes with the equipment. By the time you finish FEL3, the equipment list is darn well fixed, and even most of all the long lead pricing is usually fixed, and it's just some of the small items that are still in question. So hopefully that also allows you further adjustments as needed. But thanks for pointing that out. Okay. In code of account, I think that's pretty straightforward. Anybody have any questions on codes of accounts in general? I think that's a fairly straightforward topic. The order of the codes will vary greatly. As the example that I gave when we talked about it, some companies are very clear in that their order follows as close as you can the sequence of construction, while others do not. That's one reason why I lean on the Fluor Code of Accounts so often, because it is so orderly. Nothing is purely in the sequence of construction, because things overlap and can be done in parallel in actual construction, as many of you know. But the codes have to be sequential. They can't be in parallel. So that would be the exception. So if there's no
I
additional,
had a quick question on that.
yes, go right ahead.
So let's say there's like, I think we encountered this on the takeoffs for the assignment, but something like anchor bolts where it's not necessarily concrete. Is that something that, since it supports the concrete installation, it would go in the code of accounts for concrete, or is that like a miscellaneous code of account
We
that it
we
should go into?
we typically put anchor bolts in with the concrete because they're an embed, so
Hmm.
they aren't actually concrete themselves. Obviously, they're steel like the rebar, but once the pour is complete, it becomes a monolithic item, which falls under the concrete account.
And what about something like formwork then that doesn't stay with it afterwards?
It's required to install the formwork, so it's part of that. I'm sorry, not the formwork, but the concrete. So it's part of the concrete system. It's just not a permanent portion. So now, this is where the levels of the code of accounts vary, because you have the prime accounts, which identify concrete, and then you have a secondary level, at least in the Fluor Code of Accounts, that will identify certain concrete types. But then you have a deeper level that will break it out into forms, embeds, rebar, very detailed. Most of the time when Fluor estimates, they are staying with the concrete type. If you go to Cajun, on the other hand, they'll break it down into different activities, because they are a concrete. Well, at least the one division is a concrete pouring division. That's what they do for a living. So they're very detailed. They also did a lot of lump sum work. While Fluor, they do a little bit of everything, but they really, if they're going to specialize, they're going to specialize usually in pipe, steel, or equipment setting, and sub the rest out. But they're also usually dealing with a little bit higher levels. So when I was with them, we would bid the concrete by a model. So a type 3, we would use the model to bid it. We didn't actually take all the components off, but with Cajun we would, because it was a lump sum. The work was smaller and every detail counted more. So it's two different approaches to the same end. If that helps. And whenever we would model it, the model included formwork. It included everything, the embeds, everything. Does that help?
Okay.
Or did I?
Yeah, definitely.
Okay. If there's a sub part that I didn't quite get to, let me know and we'll talk about it.
No, yeah, I understand.
Okay.
Thank you.
Oh, you're welcome. Any other questions before we move on to steel?
Yeah, I just had one question about the project we just did. Were we supposed to account for forms in that NTO that we did, or were we just doing the NTO for the actual assemblies that we saw?
Yes, forms would have been part of it, because you have to quantify the forms you need to rent that become part of the cost of installing the foundation.
Hmm. Okay, thank you.
You're welcome.
Can I ask a question now myself? Because just to tap into this, because I forgot what we used to do on when we rent because we did add waste for the rental. Some of the form, we assume that the foundation, for example, is owned, the formwork is owned, and the curb, for example, that's rental forms. So with rental forms, do you still add allowance and waste? We added it, but I wasn't sure anyway. We weren't sure.
When I did my takeoff, I did not.
Okay.
that doesn't mean that I'm not going to say it's a hard, fast rule, because I actually thought about that myself before I decided not to. And the reason was, you could, you do a takeoff, you're assuming you need so much per lineal foot of curb. However, there's you might end up needing or renting more than you thought for whatever reason. Maybe the sequence of work causes you to buy or to rent an extra couple that initially you weren't planning. So, but at the same time, I decided not to, because I figured it's a rental. It's accounting for something over a period of time, and we'll just move that same form down and use it one more time than maybe we thought we needed to. So I thought it's going to be accounted for. And then also, since it's a component of the curb itself, that the fact that I put an overage on the curb, it might, well, I'm sitting here talking like I was using the model, and I didn't. So I'm moving back in my floor mode of thinking. Since it was a detailed takeoff, you could look at it as though you needed more of it, just like the concrete, except for it's going to come in pieces. So you don't get like a fraction of one, you get another whole piece or something. So I don't think there's a wrong answer there. It depends on how you want to approach the project and how lean you want to make your numbers as you're bidding, honestly. So it's just like, it goes back to, do you use 3% or 5% or 4% on your overage? 3% is pretty common, but if you look at the type of form, if it's has a larger face on it, and you don't put enough kickers on it, it's going to bow more than if it's shorter, tighter, or you brace it quite a bit. So it's somewhat of a judgment call. So I'm not going to fault you either way, honestly.
Professor, I had a question on the on some of the concrete takeoffs, like for the foundations and stuff.
Mm-hmm.
And experience, when you have that, like those small quantities, we didn't do it on ours as far as putting just 10 yards, because that's what a truck holds. We did a normal waste factor, but on some of the smaller quantities, I did put like a 10% waste factor, because they're such small quantities. Is that something that I know going? Is that something that you would do, is if it's a small quantity like that? Because you're either going to have to pay a short load fee or just pay for a whole 10 yards.
No, that's a very good point. If it were a full regular job, we would look at how many we were going to pour, because if we just
Right.
had 2 or 3, you're right, you'd have a short load fee. On the other hand, if you had, even though they're small, if you had 10 of them, you'll use up a whole truckload anyway. What we But the other aspect is maybe you have 100 of them, and you know that together you shouldn't have a short fee, but you don't know the exact sequence of construction. At the end of the day, this initial schedule might schedule them all to be poured together so that there's no short fee. But at the end of the day, for some reason, 4 of them or 3 of them didn't get poured and had to be postponed for whatever reason, and you have to order a short load later to finish it. Or maybe there's enough that you have 3 full trucks and then you have half a truck, and you're probably gonna get hit with a short fee anyway. So what we normally do we'll prorate a handful of short loads into the overall concrete value when we're building our pricing.
Could you do that by, I know that we've done that by just adding a waste factor to it instead of adding the short load fees. I mean, it's just another way of doing it, but
Yeah, yeah, I mean, it's legit. It's a legit practice. If you think that, if that's how you want to account for it, and you've actually thought that through, then I think it's a very legitimate way to approach it. But as long as you've accounted for it one way or the other, that would be the key. because I think we all know it. Unless the pour is about the right size or it's so controlled, you know, you're going to avoid short fees. Most jobs that we bid, we account for a handful of short fees somewhere. We know they're coming. We just don't necessarily know exactly where. And we do it. We do it through the price of the concrete. But if you don't put it in the concrete and you account for it in your quantities, you're doing the exact same thing. You've just approached it in a different area, and that's legitimate. The main thing is that you know where you did it, and I know where I did it. And the next person knows where they did it, so we know we've got it covered, and it's not forgotten.
Yeah, it's just a little bit easier for us for tech stop bids that are timed. You know, we have to squeeze a lot of them in at one time, so sometimes it's easier just to add a waste vector than create a whole new item in heavy bid.
Yeah, and that I'm not highly experienced with highway work, but it seems to me that you would have an extreme amount of long pours as you're pouring the roadway, and then you'd have a lot of one-off foundations for light poles and signs and all that very easily could be, okay, we need to pour these 5, and they don't add up to a truck. So you know you're going to have a handful of small foundations that are going to bring a short fee with them. That actually makes sense to me. Am I capturing what you're doing right?
Yeah, that's basically what I was talking about.
Okay. All right. No, good point. Thank you for bringing that one up. Anybody else? Okay. We'll move into structural steel. In the industrial world, yeah, as I mentioned before, I believe I mentioned in this class, the buildings usually are a very small portion of our overall budget. As I've noted, 0 to 5% is not uncommon. It can be more, but it's less common unless it's a very small scope of work and it happens to have a notable building involved in that small scope. So I'm really speaking of building an entire unit or building an entire plant when I make those comments. Most of our steel structures are open structures, pipe racks, supports, and as you can see here in this picture here, these are all open structures here, right through here. You could put a skin on them and close them in, and a lot of times we do, but it's still basically just an open structure with a skin on it and not really a building, because the floors are often open grading that could be poured concrete if whatever is being processed on that floor needs to be contained and they don't want it falling through to floors below. But the skin is really just acting more as a windbreak, or maybe trying to keep rain out of a certain process area. So you could have a portion of the building, like one side of the building may have skin, or 2 sides and the other 2 don't. So that's something that happens on occasion. But the main task of that structure is elevating the equipment and supporting the equipment at height. So, towers, as you can see here, stand alone. And of course, this is a stack, and I think those 2 are stacks, but that's a column and that's a column. So you can see that towers and columns can stand alone without a structure around them if they're designed properly. But often, if there's a lot of pipe that's hanging off the tower or column that needs additional support, either the column has to be designed to provide that extra support, or the open structure will help with it. The open structure also assists with vessels, tall vessels like that the wall thickness is thin enough that it's not going to withstand the wind loads, and so it needs additional support. But a lot of the time, the reason that there's an open structure is to elevate other pieces of equipment in relationship to that tower, because there's a process requirement for only so much head pressure entering that piece of equipment, or that needs more head pressure as an exit. And so it's using the elevation to add that head pressure to the process fluid. There's a number of reasons, but that's a lot of our heavy steel is involved in these open structures. On the other hand, as most of you are aware, since you are very familiar with building construction, there's not a lot of variation in the concepts of building steel structures and the steel that we're erecting here. The main difference is probably the size of the members. So a lot of our open structures like this are going to have steel structures or steel framing and steel members that resemble a high-rise commercial building, except for you don't have all the interior systems and partitions and finishes. Would that be the primary difference? So, in addition to the pipe racks and the open steel structures that I'm mentioning, you've got T supports and steel sleepers, and then miscellaneous items, which we'll talk about in more detail here in a minute. Taking the steel off, quantifying the steel, there's two primary categories. One's the rolled or extruded members, and then are just what we call basic shapes, and then the miscellaneous items. The structural steel rolled members that we're taking off, whether they're extruded or rolled, they're basic shapes. You usually can take from the steel drawings fairly easily. What you see is what you get, and it's quantified in length and then converted to weight by the type of steel. So a W8 by 15. If you got 100 lineal feet of it, that's going to be 1,500 pounds or 3/4 of a ton. So that will also fall into a category. So that tonnage will be categorized in that category. And I'll talk about that in a second. The miscellaneous steel, on the other hand, the ladders, the grading, the stairs, and so forth, they're a little more difficult because you quantify them in their unique unit of measure. Ladders are lineal foot, grading square foot. Stairs are either by tread or by vertical rise. Safety gates are each as handrails by lineal foot. And then once you quantify that, there's rules of thumb based upon design that says uncaged ladders are 17 pounds a lineal foot. Caged ladders are 27. Of course, that's assuming a particular design, but it gets you within proximity. So, the uncaged ladder may actually be, 16, 17, or 18 pounds, and caged might be 25 to 29, depending upon how many bars they put around the cage to keep everybody in. Now, if you were to take off, for this example, 45 feet of vertical ladder, the bottom 7 feet of ladders are always uncaged, because if they were caged all the way to the ground, you could never get in them. So the most accurate way to take that off is always subtract 7 feet, apply 17 pounds per lineal foot for the uncaged portion, and then apply the caged weight to the balance of the length. Sometimes people just say, I've got 45 feet of cage, and they hit the whole thing with 25 pounds per lineal foot. And effectively, by doing that, all you're doing is adding in a little bit of an allowance, kind of a contingency. And if you do that, then you are fattening your quantity takeoff, but you can compensate by not adding design allowances or something of that nature, which will then bring the padding back down. So again, it's how accurate do you want to be as you perform your takeoff. The more accurate you are, the more reliable your numbers when you're finished. But when I second, I mentioned the categories that the weight would fall into. I talked about a W8 by 15. A W8 by 15 naturally falls into the light category. So we quantify all of our non-miscellaneous steel into these categories: light, extra light, light, medium, heavy, extra, extra, and extra heavy. Not everybody recognizes all of these categories. Some companies do, some companies don't. I've worked with some companies, they only recognize light, medium, and heavy. And so for them, light is 0 to 19.9, medium is 20 to 39.9, and heavy is anything over 40. Some may adjust their medium to be 20 to 60, and then anything over 60 is heavy, and that's all they count. Others will recognize light, medium, heavy, and extra heavy, but just drop the two extremes that you have here. So why is that the case? Why do we have these categories? As steel gets heavier and heavier, you are moving more weight with the same motion effectively. So the connections take similar amounts of time and effort, from the standpoint that whether you're regardless of the type of connection, each bolt takes so many minutes to handle and the thread and tighten. We don't use rivets anymore except for special occasions. But the picking up, the rigging, and the movement and setting of those members take less time per pound as it gets heavier and heavier. And therefore, the hours per ton that you apply to each one of these categories increases as you move from the heaviest to the lightest. So we would consider extra heavy to be somewhere in the neighborhood of 8 to 10 hours per ton, while by the time we get to extra light, we're at 40 hours per ton, because it just per pound, it's more effort. Companies that don't recognize the extremes or only recognize light, medium, heavy, they approach things that way because they don't deal with the extremes very often. The majority of their work is in the light, medium, and heavy categories. So they're not even worried about touching steel members that are over 160 pounds or much over 80 pounds, because they just don't see it very often. And so it's a one-off for them. So they're focusing on their core activities and their core expertise. On the other hand, the extra light versus light topic, that's just an effort by some companies to be more exact, while the companies that don't recognize extra light, they're saying that the law of averages is going to take over. And so we don't put a little extra time on our extra light stuff. We're going to balance out at the end of the day, because our work practices say we will, and our histories show that we will. So there's some variation in the approaches, but the approach is generally fairly consistent. And I've seen some variation in these weight categories as I've moved from one company to another, and I've dealt with some suppliers, but most of them are really close to this. I haven't seen much variation in that.
So a quick question, just if you don't mind, back into, and it's, I'm sorry for jumping the gun. For pricing, for example, the extra heavy, let's say for 20 ton of light and 20 ton of extra heavy, the price with the extra heavy will be higher because it's bigger sections and heavier?
No, it'll be much less. The same principle of cost is applied that is with the labor. So 20, well, give me one example. A lot of miscellaneous steel runs in the 4,500 to 6,500 per ton range. Your light and extra light is similar. It can run in the 45 to 5,500 range. Meanwhile, your extra heavy members, they can be as low as $1,900 to $2,100 per ton. And the primary reason is that as they're extruding and rolling these members, there's much less work involved. It becomes more pure material. While when you're dealing with the extra light and even medium, those items, they're having to put a lot more handling and a lot more rolling and a lot more effort into that steel as they produce it. I will have to back up and make one exception, and that is usually when you get into the extra heavy category, you may be looking at a girder and not a rolled member. And
That's exactly what I was thinking of. This is why in my
yes,
mind it cost more to build. You're gonna
yes, it will.
rent an 80-ton crane or something to put it on.
Yeah, well, the difference between a girder and a rolled member is that the extra heavy rolled or extruded member and the extra heavy rolled or extruded member, they're like I'm saying, the effort to produce it per ton is less. However, a girder is fabricated. It's actually several other shapes assembled and put together to create a beam. It's not milled, if you know what I mean. So now when you buy that girder, that girder has assembly labor in it other than just pure milled.
Oh, you're talking about built up sections.
Yes,
Like you're buying plates and then you're welding those plates together to create an I-beam, and then you put
yes,
angles there to strengthen them, splices. Oh yeah,
yes.
now I remember. Now I know what you're talking about. Yeah.
Yeah, exactly. So those are going to be more expensive. So the price will get cheaper and cheaper per ton. Now, 20 tons of light steel, of extra light and light steel, will be much more expensive than 20 tons of extra heavy steel. However, you're going to purchase members of extra light and light in pounds almost, while you're going to be buying extra heavy in tons. So it will cost more because you have so much more weight, but the cost per ton will be less. That
Yes.
makes sense. Yeah.
Yeah.
So-
That makes sense. Yeah.
Yeah. Good question though. Thank you. That's a good question. I like it. And you also reminded me to talk about the fabricated girders, which we deal with them so rarely. It's don't think about it too often, but I think whenever I was watching them build the bridge here at the Grand Parkway, which is Highway 99, and the West Park Tollway, which is Highway 1093 for those that don't live in this area. And it's we have a lot of mix masters down here that are quite tall, and the span is incredible on some of these. But as I was watching them drive up with these beams on the trucks, I was noticing that they're about 8 feet tall. When you look, as you're driving under them, you look up, they look like they're about 4 or 5 because they're so high and so far away. But whenever they're on the ground and driving by them, you realize they're much taller than how they appear. I'm quite sure those were girders. They were fabricated out of steel plate, and I don't think you can roll anything that big. But I found it quite interesting as I watched it go up, and also where the moment connections were in those things too, because they didn't connect over the support, they connected in the air. So the connection point's not directly supported. It's a moment support that has just a multitude of bolts through it.
Oh yeah. The splice plates. Yeah.
I
Yeah.
thought that was quite interesting. But thank you for the good question. Thanks. Miscellaneous members. So whenever I mention miscellaneous or we talk about miscellaneous, we're talking about ladders, handrails, safety gates, stairs, grading, checker plate, flat plate, and monorail. So it's their unique items that they're like light, medium. They're labor intensive per pound, and they're unique, and they have their own unit of measure, as I was mentioning earlier. And so we have to address them separately, and per ton, they're expensive, and per ton they require a lot more labor. Most of them have some variation, like I mentioned. Ladders can be caged or uncaged. Handrails have quite a bit of variation in them. You can have 2 or 3 rails, and they can come with or without toe plate, and they can be pipe or angle iron. Theoretically, they all weigh, if as long as they have 2 rails and they have a toe plate, the pipe and angle weight doesn't vary too much. And if they both have 3 rail and a toe plate, again, they're very similar. So the pipe and angle there is some variation, but we typically don't account for it. To be honest, that's kind of leaning back on the law of averages, that we're close enough. If you do, when it comes to stairs, I mentioned earlier, there's 2 ways to quantify that. One is vertical distance, so many pounds or tons per vertical distance. The other one is by tread. And actually there's a third way, and that is you take everything off separately. You quantify the handrail separately, the stringer separately, the cross bracing separately, and the tread separately, and then add it all together. But one method is taking off the stairs and adding, I think it's 90 pounds, 95 pounds per tread. And it's supposed to cover the stringer and the cross bracing and the tread, everything except for the handrail. And then the third is, if you have a, and I want to call it an allowance, but that's not true. If you have a weight per vertical foot, rule of thumb that you would use, then for every vertical foot, you're going to say it's so many pounds, and that covers all of it, except for the handrail again. So that's 3 different ways to approach the stairs. The rest of them are pretty straightforward. It's the ladders or lineal foot, handrails, lineal foot, safety gates are each grading, checker plate, and flat plate are all square foot, and monorail lineal foot. Now there is variation in the grading. In the grading, the plate and both plate types, and that is the plate thickness can vary. So there's not a lot of difference in the weight of checker plate and flat plate, but the thickness will change your weight. So for every 1/8 of an inch thick, a square foot of steel, just standard carbon steel, weighs approximately 5.1 pounds per square foot per 1/8 inch. So if you have 1/8 inch plate, it's 5.1. But if you have 1/4 inch plate, you're now at 10.2 pounds per square foot. On the other hand, grading, there's variation in the thickness of the bars they use, and there's variation in the depth of the bars. So there's at least 3 different types out there. And then you start taking consideration fiberglass options. Your grading can vary in weight. So it's good to research what it is. I think typically it's 3/16 inch thick bar, and it's about 1 1/4 inch, 1 3/16 inches is your standard depth. And if you don't know any different, you can use that, and it runs about 9.1 pounds per square foot. But it's good to make sure, because if it's 1.5 inch deep bar and it's 1/4 inch thick bar, it's going to weigh a fair amount more than what I just quoted you. It'll go to like 10.7 pounds per square foot, something like that. All right. So whenever you're performing your quantification of your steel, there are several things to keep in mind. One is the actual drawings themselves that are illustrating the steel members. But usually there's two other documents you need to make sure you're referencing as you're performing your quantity takeoff. And that is much like the foundations that you just finished with, particularly the building one. And that is your drawing specifications, and there's usually details. So you'll have one sheet that has common details that will outline what your typical base plate looks like, what your typical connection looks like, what your typical bracing may look like. It may identify some standard beam sizes or column sizes. And if you have any special connections, it will also define or illustrate those, such as a moment connection. It'll usually will break out and show you a standard typical ladder and a standard typical stairway. So when you see stairs, it won't give you a lot of details. It'll just give you a reference number that will take you back to your standard details to look more deeply, more closely at the design of those items. But when I talked about standard beams and columns, what I mean is that there are occasions where it will just say W8 or W10, and that's all it will say. And you're going, well, what is it W8 by 15 or is it W8 by 27? What is it? Normally, when the drawings do that, you have to go back to your specifications or your standard details, and it will say that anytime that you see W8, it means W8 by 15 or W10 by 21 or something like that. It'll tell you what the standard is. So now every time you see it, you just know right off the bat it's a W8, whatever it's supposed to be. And then if it's unique, then they'll put the full description on there each time. So this is a typical, it's a little bit simplified, but it's a typical cross section. In fact, this one here, it looks just like what you will be dealing with. And so in the case here, remember that even though the flange ends right here, the webbing still is here. And so this beam is going to reach all the way over to the center line. And so you want to take the full length of the center line on these items. And so it's telling you this is WF 10 by 15, and you have 4 of them and they're 8 feet long. So literally it'll be 4 times 8 times 15 pounds each divided by 2,000. And now you have your weight of your beams for this particular bent. Your columns, you're at 19 feet, top to bottom. Now, if you notice, if we want to be particularly specific, it actually is 19 feet minus 2 inches. We have 2 inches of grout here. But I don't ever take off that, because it's, number one, it's a small amount of weight. It would be basically 2 inches divided by 12 times 26 divided by 2,000. It becomes insignificant. You could also even count it as part of your waste allowance or design allowance if you wanted to. If you want to be extremely particular, you can go ahead and subtract it. I don't. Now, on the other hand, we typically don't take off this base plate and the angle iron connections that are going to be in this webbing connection right here. We normally don't take those off either. What we do is we'll take off all the major members that are defined by the drawings, and then we add connection allowances. And the connection allowances for light and extra light are around 12%, By the time you get to extra heavy and extra heavy, you're down to around 4%, because most of your connections are made of medium and your lighter heavy steel members, and so the ratio decreases as your steel members increase in weight. So your, in this case, your columns would be 2 times 19 times 26 pounds divided by 2,000, and that would give you your weight for your columns for this particular bent. And if you know you have 50 bents, then you take those two weights, multiply times 50, and you now have your weight for all the bents. So it's fairly straightforward. I think structural steel is one of the most straightforward. Where it becomes challenging is when you have a very busy drawing, because pipe racks can be taken off very quickly, just like they can be erected. Open structures they're a little more complicated to erect, because there's a lot of members that are interacting with each other, and they're also a little more difficult to take off because there's a lot of members involved, and they of various types and sizes. This is also a very good time to quantify your grout. So even though grout falls inside typically of your concrete code of account, I won't say all companies put them there. Many companies do. This is still the best time to take it off, because you're looking at where it's needed and you can account for it. So by the time you're done with all your steel structures, you know you have all of your grout underneath your steel structures, and then all you're left to figure out is your unique grout pores that are kind of a standalone for whatever reason that might be, and then the grout that belongs to your equipment, and you can take that grout off when you're calculating your equipment or installing your equipment. And when you're done, you should have all the grout required at that point in time. Any thoughts or questions there?
I
Just,
had a question on this real quick.
sorry. No, go ahead. I'm sorry.
So on the assignment, there was some sections of some of the pedestals, and they were showing grout underneath the base plate, but we only saw it in section and not in plan. So I was wondering what the right way would be to quantify the grout.
In that case, let me answer that in two parts. In the case of that exercise, I went ahead and quantified the grout roughening and the grout requirement because it was kind of a standalone. In reality, if we were performing a regular project, I would have held off from quantifying the grout in the concrete like we did, and I would have quantified them here. The reason being is that here you have a better view of what your base plate sizing is. On that one, you have to assume, because it didn't talk about the base plate sizing. It just showed you where the anchor bolt pattern was going to be. And you would have had to have looked at the steel structure to find out what your base plate sizing would be, because normally your grout needs to fill up the base plate and then angle at a 90 degree or a 45 degree angle from the edge of the base plate. In some cases, I've seen it where they require you to go an inch past the base plate and then do your 45. Very rare, but I've seen it a couple of times.
I'm not too familiar with grout. So is there a reason for that 45?
Yes, to keep it from chipping.
Oh, okay.
Now, I've shown you some pictures where they actually had the grout go straight down. But it's the vast majority of the time when I've seen it I don't know, since I can remember, it's always calling for a 45 off the edge. And the purpose of the grout is because when you think about it, when you set that beam down and tighten that base plate, it's already level because it's sitting on shims. However, by filling in that base plate with non-shrink grout, then as the shims slowly compress over time, the grout will then start sharing the load slightly, but the load's still primarily on the shims. So it's helping with that support, but it keeps moisture out from underneath there, and it helps with the load slightly, because it's, concrete's better in compression than it is in tension. But again, you don't know how much grout you need until you know what the size of the base plate is.
Okay, that makes sense. Thank you.
Yeah. And one additional thing is that if you notice here, it tells you 2-inch grout spacing. If you go back to the concrete drawings, it doesn't really say what the thickness is. It's the drawings, the steel drawings and the equipment drawings, that are actually requiring the need of the grout, they normally will tell you what the parameters need to be. So that's another reason why I would wait till here. So honestly, I was a little bit premature in taking them off in the concrete section, but I was doing it more for practice than anything else. So if that makes sense.
Yeah, that makes sense.
Muhammad, do you have a question earlier?
It's two questions, actually. The first one, I was just trying to check. The joints for the miscellaneous steel is about 10 to 15, you said, or 10 to 20 of the weight?
Oh, the connections?
Connections, yeah.
Yeah, on the light and extra light, we usually apply around 12%, and then medium 10, heavy 8, extra heavy 6, and then extra heavy 4, and then extra heavy. We just stay with 4.
Okay.
That's my memory.
Okay.
I'd have to go back and actually verify that, but I'm reasonably sure that I'm right.
Okay. Are we since we
That's why I wasn't ready to take notes.
since we have about 5 minutes left on the class, quick question for you. Are we gonna go just to have a I downloaded the assignment and I'm looking quickly through the drawings. Fairly to assume, is it fair to assume if like one of the drawings, they have the X, like they are tying up the 4 columns together with
Cross bracing?
2 lines? Well, this is what I'm asking. There is nothing to indicate that it is cross bracing. It's just 2 lines. I'll give you an example. S105.
Mm-hmm.
Because I'm used to cross bracing on the side, not on the bottom, not on the plan view, but on the side view. You know what I'm saying?
Oh! You're talking about the plan view. I thought you were talking about the side view.
Yeah, if it's cross bracing, they will put I'm guessing they will put the section on it.
No, I'm pretty sure that one's cross bracing also. It's keeping it square.
But there's no detail of that in there.
Yeah, I think in that case, if there's no detail, make an assumption.
Oh, okay.
I think
Right,
remembering
the question.
correctly, I think I thought I looked at it as 3 by 3 by 3 by 3/16 angle iron is what I remember doing in that case. Something like that. I repeated what was being used before, because that would have been a reasonable assumption.
Okay. All right.
So-
I didn't have time to look at a lot of things. just
So, Professor Whitman, you did say, to always keep in mind the specifications as you're looking through the details.
Yes.
Going through the drawings really quickly, I did
Mhm.
not see a specification page. So, what specifications should we be using when we run into the details not giving us enough information? Such as Hosni was just pointing out what looked like maybe just cross bracing, but we weren't sure.
Yeah, at that point, if you're taking something off and you don't have enough information, that's where qualification becomes important.
Okay.
Because you always qualify to
Okay.
what your basis is if there's any question. So, and that's more or less what I was doing. Yeah, this one here is fairly straightforward, so it doesn't include, and and again, this goes back to, we're not trying to get too deep in the weeds. We're just trying to get everybody comfortable with the general concepts. So I didn't provide a full set of specs with all of this. So it's all going to be ASTM base specifications for it, and also assume that the grout is non-shrink. So there's no real rotational moments or anything to worry about using epoxy grout in this case. But that's a valid question, valid statement. That in a real job where you have involved procedures, you want to lean back and check your specifications within reason. Obviously, we can't read everything all the time, but to the maximum extent reasonable and possible.
Sure, sure. And then, and one more question.
Yes.
On Thursday's class, are we going to run it pretty much the same way that we did last week?
Yes.
Or we'll have some time to break out and all that?
Yes. We'll
If so,
Uh-huh.
if so, because what I would really like to do is the plan drawing S203. It's a very detailed drawing. It's showing the actual grading, what looks like it's a plan elevation. There's ladder details, there's walkway details, there's handrail details. If you could just go over that just a little bit for us at the beginning of that class, because I'm not familiar with this type of structures, and I want to make sure that when I'm looking at these dimensions and what I'm thinking is being steel,
Mhm.
you know,
Okay.
there's
Oh.
just a couple of details on here that I'm not familiar with. So that'd be
Okay.
very helpful.
That'd be great. We'll do it. So that's a good request. Very
Thanks.
good.
Cool.
Okay. Is there? I thought there may be one more question. Nope. Okay.
Yeah.
Well, I know we're technically out of time. I was going to try to shut off by 1, but I'm actually doing okay right now, so I'm going to keep going. I'm going to skip over the building MTO section because I think there are quite a few people here that are very experienced with this, and also this is posted so you can look at it. What I will say though is that this particular task is going to focus on, well, the steel task is one task. The building takeoff is yet another separate task. So when we get to the building task, it's going to be more focused on interior partition quantities and counting some plumbing fixture. It's going to kind of touch on a few things, but not, it's going to be very high level because there's enough of variety there that it'll take a fair amount of time, but I don't think it's over the top, but it will take enough time as it is. Add any more would just really make this a long, tedious effort, which is not the intent of the class. I would like to move on quickly and talk about mechanical equipment. I know we're already out of time, but this part there is no task focused on taking off equipment, so I want to talk about it because this is probably one of the areas that everybody's least familiar with, unless you have industrial experience.
This is the only area I'm good at.
Really? Okay. Well,
Yeah,
sorry.
I'm Chevron Phillips, so I'm on the client side.
Sorry to take
All right,
away
sir.
from you, Stephen. So other than Stephen and myself, most everybody's probably not that familiar with these items.
Can I very quick question before
Yes.
when I did estimating many moons ago, I always stayed away from that because of what you just said. Now I'm a civil engineer. I don't know how to even comprehend how to do mechanical, but I noticed they do something both electrical and mechanical. They do the point system, and they can look at a drawing and say, okay, this is 6 points. And then they start calculating a price per square foot. Are you familiar with that?
No. Oh, you're thinking of buildings?
Buildings. Yeah, building, not
Yes,
this one.
yes.
That definitely I never done in my entire life.
Yeah,
Except
that what I'm used to from that standpoint is I understand. I think I understand what you're talking about. I've looked at mechanical building construction mechanical two different ways. One is per square foot. So
right.
you're assuming that it's, we've got a building, so we're 350 per square foot, and that kind of accounts for everything from the
Right.
from the water heaters and HVAC, well,
HVAC,
water heaters,
yeah,
plumbing,
yeah.
everything. That's one way to approach it. Well, the reason why that's a little bit of a thumbs up kind of high level is because one building may have one bathroom per floor and the next building may have two. So you've got twice as many fixtures and twice as much plumbing for the same square footage,
Mhm.
depending upon how they designed it. On the other hand, if you use the point system, and what I think you mean by that is you count the fixtures, you know that each fixture is going to require supply and drain. And so, and you know that a water closet generally costs so much, and then all the associated plumbing with it, and a urinal and a sink, they all cost so much, because we used to price electrical that way as well. A light
Oh, that's
fixture,
exactly the electrical used to drive me nuts when they talk about the point system, and I have no idea what that is.
that's well, what that is that if you have a light fixture, you have a home run at least back to your switch, or at least next to the net, because you usually daisy chain all your lights and also your receptacles. So you've got to run at least back to your next receptacle or your next light fixture, and then the next one goes to the next one, next one goes to the next one, and then the final one drops to the switch, and then the switch is what makes your home run back to your main panel. So by counting light fixtures or counting receptacles, or counting certain things, there's a certain amount of bulks related to it, because they'll run it through some basic conduit or things of that nature. So that's how that pricing is done. Is it's an assembly approach.
Okay.
Now this differs because this is industrial mechanical equipment. And when I talk about equipment, I'm talking about a tank just like this, or I'm talking about a clarifier just like this, or a pump like this, or a compressor like this. This is actually a reciprocating compressor right here with a fin fan air cooler behind it. While this is this one right here is a centrifugal pump, and this one here looks like a gear pump just by the structure. This clarifier here is separating, since it's above ground, it's probably in a paper mill, and it's separating garbage from the pulp itself. While this is a storage tank in a tank farm, in a oil refinery, or a company that receives and a transfer station. So the MTO for equipment is extremely simple, because basically you've got an equipment that looks like this, and it says, here's your equipment and here's your count. And so there you have it. It's that straightforward. Where you have to be careful is going back to key quantity and whether you should count the equipment or not. The reason that's important is just because you have a particular method for counting your bulk materials in a key quantity, you need to count your equipment based upon specific parameters, because if you don't, you throw all of your metrics out the window, because more than anything, your mechanical equipment is your fundamental metric. You'll have metrics for installing and pricing all your bulks, but all your bulks relate back to your equipment, because in the end, your equipment is directly driven by your process. So a company has been tracking their histories well, will know that, oh, for low density polyethylene or for chemical plants in general, we have these metrics. For every piece of equipment, we have so many cubic yards of concrete, lineal feet of pipe, lineal feet of cabling, so many number of instruments, and so many tons of steel related to each piece of equipment. And then from that, if you have that ratio, then from there you can go, well, we know for every ton of steel, it's 35 hours a ton, and it's $3,750 per ton, and so on and so forth. And the metrics they're really good for factoring if you have nothing, and they're really good for checking your detail estimates when you do have a lot of things. So what are the rules of thumb? For it to be counted, you need to answer at least 3, if not 4 of these questions in the affirmative. Does it have its own foundation? Does it require its own power? Does it have its own pipe runs? Does it have its own controls? And is it going to be set? Is it one particular pick and set, one lift associated with it? The reason why you can't say this for all of them is if you go back to this tank right here, this tank doesn't have any power. It's just a tank. But it has its own foundation, and it has pipe running to it, and it has instruments on it. And so it's its own item. It needs to be counted. Meanwhile, there are times where if this were this is a small reciprocating compressor here. If it were large enough, it would come in probably 10 truckloads and have to be assembled on site. It would just be, everything would be bigger and be more of it. Each one of those items doesn't get counted, including the motor. The motor should not be counted. The compressor as a whole should be counted, whether it's large enough to be assembled or whether it's a skid package like this one that's going to set in one pick and one lift. Well, one lift and one set. Your large pumps, most of your pumps come skidded like this. Pulp and paper plants, typically the motor will come separate. But pulp and paper chemical plants, they normally come pre-assembled, and you just set the whole thing, but you still have to make 3 alignments. This coupling has to be checked 2 to 3 times during the process. But in this case, it has its own foundation, it has its own power, it has its own piping, and then somewhere, you can't see it, but there's probably at least one instrument on this that is checking for vibration, and then just away from it, there's going to be instrumentation checking pressure and flow at monitoring, what's going in and coming out of that pump. And in addition to pressure, it'll be a differential pressure in addition to that. So if you can answer the affirmative a number of these, and you count it. And so what ends up happening is that the compressor skid is a 1 each. It goes into your estimate as 1 EA. The compressor that's on that skid, you can input as a 1 EA period, so it doesn't count. But you might have, in the motor, would be an EA period as well. You could list in your estimate, you could list just the compressor skid, and that's it. And then account for the CFM and account for the power and the weight and everything here, and just roll all this up and put it on one line item. Or you could list all 3, include this particular information with it, but you're only going to labor it one time, because you've got a 1,500 pound, you've got a 7.5 ton compressor that's 6,500 horsepower, and you're depending upon how your company looks at it. Some companies labor all the equipment by weight, others will labor it by type and capacity. And so if it's a tank or a vessel, they're stagnant, they'll install by weight. If it's a compressor, it's like what type of compressor and how many horsepower. If it's a pump, what type of pump and how many horsepower. that type of thing. If it's a heat exchanger, it may be either by weight or it could be surface contact area.
Can I quickly ask a question? Do you
Yes.
actually, from what I'm looking at, you actually tie the price to the horsepower, like the point system in electrical? Do you do that?
The price, if you have histories, you can price it by horsepower, but it needs to be by horsepower and type. Because to give you an example, is that if you have metrics that tell you that pumps are $1,200 per horsepower or something of that nature, that's probably true for centrifugal pumps, but reciprocating pumps might be $1,750, while
PD pumps would be a whole lot more.
the what now?
The PD pumps.
Yeah, positive displacements. Yeah, they're more. Reciprocating will be more. And you've got diaphragm pumps, you have gear pumps, you have screw pumps. So, and they all vary in price. So now the labor doesn't vary as much, because in each case you're picking up a skid that's primarily pre-assembled. You're setting it, leveling it, filling the base full of grout, and you have to check the coupling, and you have to check the seal type. But outside of that, the seal is going to vary a little bit. So your labor is going to be very similar, but your price can be very different. So the point system, as you're calling it, works, but you have to have multiple lists of point systems so you know what type and horsepower.
Okay.
Normally,
cross-reference. That's important. Yeah.
yes. Normally, as estimators, we approach this is we go to our procurement department and go, how much are these pumps? and they go out and get a quote for them, and then we input whatever they come back with. If it's a very early effort and we're dealing with a lot of unknowns, then we might be able to factor things and go back to the point system. And we used to actually, I'm old enough now that a lot of the programs we have today didn't exist. And so I had formulas where, well, if I knew the pressure and the volume, I could calculate the brake horsepower. And then I knew that plus or minus 30%, we can use so many dollars per horsepower. Now we have what we call, it's AspenTech ACE, and it's an extremely powerful program. And so now we'll go to ACE and go type, horsepower, volume, capacity, pressure, specific gravity, whatever. We type all that in and it will calculate a price for us. So we've gotten a little bit lazy from that standpoint. Those of us that used to do it by hand have gotten a little bit lazy, spoiled, maybe a better word by that. The younger folks that have never even had to do it the other way, that's all they know is, well, I'm going to go to ACE and type it in. They're lost without it.
How come you didn't put the pump motor on pumps 2 Alpha Bravo and 3 Alpha Bravo, but you separated it out on the compressor?
Because that's how the pumps come. The motor on that compressor, well, that's how it was received. So that's how it was given by the vendor. So pumps often unless it's pulp and paper, come already installed. Truth is, the compressor did too, but they actually had to purchase it separately, send it to the vendor, and then install it. So the engineers at the time define it separately. So that's all I can say about that. So the numbers that you're looking at are somewhat real in this example here, but I can't disclose what, when, where, or how it came from, because that's all proprietary. So if you don't know that, it's just a list. It doesn't mean anything. If you knew all that, then you know where it came from, and you'd be able to understand something that somebody doesn't want you to know. So so from this standpoint, it's just a list. That's all I can say about that. But going back, one thing that if you have the time as an estimator, if you have the time One thing I've always liked to do is check my drawing list, my pipe list against the PNIDs, and check my instrumentation and check my equipment against the PNIDs to validate that what I've been given by engineering is accurate. It matches. Truth is that if it's a small enough project, you can do that. If it's a large enough project, it almost becomes cost of it's just too expensive to pay somebody to spend the time. You just have to trust engineering, because I've worked on jobs that were just 10-20 million dollars, and we only had 10 PNIDs, and it was doable. I could do it, and also I cared about it, so I did it. Some estimators don't care to be that particular, but when you have a multi-billion-dollar job and you have hundreds, if not 1,000 plus PNIDs, and each one of them had multiple pieces of everything, it's too much time, too costly to go through and validate that. You have to trust engineering at that point in time. The reason I make this point is that I've actually found errors that engineering had passed on to me, and I then sent them back and said, you show this, you show this. I think this document you gave me is right. Can you validate one way or the other? And they're like, oh, hey, great, thanks. And they went back and they corrected things. So they just started moving too fast, and they got lost in the shuffle. And so I was able to help them. It helped my estimate be better, and help them get their engineering items lined up. Now, inputting the quantities of what I'm showing you here is, like I said, it's very simple, very straightforward. You just need to take enough time to make sure you put your unit of measures on there properly. The real challenge with the mechanical side is making sure you labor it and price it properly. Because you can look at this here and go, oh, well, it's just such and such reciprocating compressor, and so it goes in that quickly. But you really, if you're doing it properly, you'll go, okay, we got a compressor, it's centrifugal. The picture I showed you was reciprocating. This is a different compressor. It's centrifugal, it's 6,500 horsepower. Okay, that my charts say that's going to be 1,500 hours to install. However, you need to go back and check the purchase order, and whoever's doing the estimating should go back and ask procurement for the purchase order. Say, can I see your purchase order? I want to make sure this is all coming pre-assembled, because if it's not, all of a sudden the 1,500 hours doesn't apply anymore. It's now you have to take that and start adding everything that's coming piecemeal into it. And so it's never, a lot of people will just start throwing hours at it and say, I'm done. It's like, well, wait a minute. Are you really? Did you double check? But we'll talk about some aspects of this when we get to our very last class of the semester, because as potential managers of this process, you have some decisions to make. And that is, are you going to squeeze everybody on time? And that way they don't have time to go back and double check everything. They just need to get it in and get the best number they can on there and move to the next thing so they can finish. On the other hand, if you give them enough time, they can do all these validations, but it costs more money because it takes more time. So you've got that balance you have to fight as a manager. All right. So that's it. We're once again run over, but as long as nobody minds, it's I'm glad to be able to do it. Today,
I was going to ask you a question
Yeah.
too, but it's all right. I'll
Okay.
wait.
No, go ahead.
No, it's in the assignment. I got a quick moment and I leaned through it, and I just want to make sure it's not like the concrete. You did not add anything that's not related to the layout in the first two drawings. Everything is related to each other, correct?
No. The,
Okay,
yeah,
that's why I wanted to ask, because the last few drawings don't look like they are related to the first.
Yes, that is correct. The
Okay.
just like the concrete, where the first 4 were building focused and the second
Okay.
4 or 5 were industrial focused. This
Okay.
one here, the first several are well, you get 2 different numbering systems if you notice, and one, the TS is a tower structure,
Mhm.
and that everything that's TS is related to each other. And then the other one, the other set are that are just S numbers. That's a pipe rack.
Yeah. Yeah. So the
So-
tower structure 202 through 206, those are one project, kinda, or one part of the project. And the S100 through 109, they are related to each other. Make
That-
sense?
That is
Okay.
correct.
All
That's
right.
correct.
No, it's just, yeah. It just, the reason why I did that is this is how we manage to break ourselves into subgroups. So this way we can divide the work, divide, conquer, as they say.
Yes,
So-
yes. I'm a firm believer in divide and conquer.
Yeah,
but-
yeah. I already got what you. Yeah, that's why I asked the question. Thank you.
All right, no problem. Good question. Okay, so today task 1 was due and the reflection 1 was due. Thursday will be open class again. We will spend some time going through the drawings before we break out into sessions, and then we'll break it. We'll then move into our breakout rooms until the end of class, and then everybody can ask questions as needed. And then task 2, which the steel is task 2, and the reflection that is affiliated with it will be due next Tuesday, and by 6 o'clock, just like today.
No reflection.
And the reflection as well. Yes.
Okay.
I think you're going to find the pipe rack steel pretty simple. There's a lot there, but it's very repetitious. The tower structure is more involved. It's a small structure, but it is more involved. I think I did it by myself, and I think I did all of it in about 2.5 days on working evenings. So basically, 2 evenings and a Saturday afternoon is what it took me to do by myself. So I think it's going to stretch you. I think the tower structure is going to stretch you a little bit, but I think it'll be
It's
fairly
got more details. It's got a lot more details.
Yeah, a lot more. There's a lot more variation in the sizes, the members involved.
Yeah.
And
Okay.
you're going to on the pipe racks, you've got a few elevations, and but it's very repetitious. One thing to remember about the pipe racks is that when you look at those elevations, you're looking at the bents, and you don't really see much of the beams that run between the bents, except in the plan and 1, maybe 2 of the elevation views. So keep that in mind. You may have to make some assumptions there relating the sizes and stuff. But it should be fairly easy to visualize. The tower structure, you're going to have to go back and forth because it's got elevations and plan views you have to go back and forth on. But again, we'll touch on that Thursday before we break out into our sessions.
Okay. Appreciate it. Do you have something to share with us too, like your own takeoff, just to see the level of detail you're expecting?
I can give you a quick glimpse of that.
Okay. All right. That would be good.
So my intent when I show you those is to show you how I'm breaking it out. But my intent is not for you to take my quantities. It's I want y'all to do
Oh,
that.
no. I just, we need to, because the way we set it up, we do the takeoff and then we check each other's because we broke the project. So the whole point is just, but what is the level of detail?
Yeah.
That we're talking about? This is important because for me personally, I don't know
Mhm.
about the others, but for me personally, I got to the point of my career that I don't even go to that level of detail. I just look at the bigger picture, square
Yeah.
footages, that kind of stuff.
Yep, yep. And that's that.
So, and that's not a schoolwork. That's gonna mess me up with the school. So that's why I'm asking.
And one thing while we're on that topic to keep in mind also is that if you take the steel off, you can put a factor like an allowance against it to account for this your connections that way, or you
Right.
can create a separate line item for the connections if you wish. And
That's what I was thinking of. But then
you
in
can go
the
either way.
yeah, but then the quantity itself is gonna be percentage still from the steel above.
Say that again.
Like I'm splitting it, but it's still percentage because there's no way for me to go down to that level of detail or that there's any
Right,
detail
yeah,
that shows.
Yeah, all
Yeah,
the connections are percentaged either way.
Yeah.
And I'm trying to remember if I put connections on the steel when I took it off. I have to go back and look at what I did. But if I didn't, I should have. But I'm pretty sure I did. So, okay.
Okay.
I appreciate it.
Okay.
Good
Thank you.
question. Any last minute questions before we once again we're hitting 7:45 instead of 7:15, so don't
Hey,
tell them.
Okay.
Hey,
Yeah,
one more. Can you create breakout rooms so I don't have to try to figure out how to do that real quick, please? If group 5 wants to meet up, please.
Oh, right now?
If you could, it'd be cool.
But when I drop off, it'll kill everything anyway.
Oh my goodness.
Yeah.
Come on, Steve, it ain't that hard.
Oh, I'm a Teams guy. Damn it.
Yeah, me too. I'll
Me three. Me
Teams is
three.
easier. But once we get up
Hey,
to speed,
Team 5, I'll text you if you got time.
so that will give you a thumbs up, but you just couldn't
I
see
don't think any of them are here, to be honest.
it. Okay. Okay. Any other last minute questions before we drop?
Thank you, sir. Thank you, sir.
Great.
All right.
Y'all have a great evening.
Thanks, Professor.
Same to you. Take care.
You're welcome. You're welcome.
Thank you.
Thank you.
You're welcome. Have a good evening.